Welcome to the math record. Today I'll cover the fourth convergence test, the ratio test. So if we're given a summation from 1 to infinity of f of x, and if we take the limit as n approaches infinity of f of n plus 1 and f over f of n, and take the absolute value, and it comes out as some limit L, then if that limit is less than 1, then it's going to be converging. However, if the limit is greater than 1, or if the limit doesn't come out as a number but infinity, then it's going to be diverging. So to understand this, let's think about what's happening. So the next term divided by the previous term, if that is less than 1, that means the next term is smaller than the previous term, then it converges, which makes sense, because if the number is getting smaller each time, then the sum is going to sooner or later reach a limit. Now, if the limit is greater than 1, then that means the next term is bigger than the previous term. That means our sum is getting bigger each time without slowing down. So that means it's got to diverge. Now, if our limit is infinity, that means the bigger one is increasing at a really fast rate compared to the smaller one. So that means it's going to be, the area is going to get bigger each time, which makes sense for why the ratio test works. Now let's try to do this with some examples. Let's say we have the summation from x equals 1 to infinity of e to the power of x divided by x factorial. Usually you're going to use the ratio test for exponentials or factorials. So the limit as n approaches infinity, absolute value. So we first substitute x with n plus 1. So e n plus 1 divided by n plus 1 factorial divided by, now we substitute x with n, e to the power of n factorial, our absolute value, and that is equal to the limit as n approaches infinity. So dividing is the same thing as multiplying by its reciprocal. So n plus 1 factorial multiplied by n factorial over e to the power of n. E to the power of n, e to the power of n plus 1 is just e, because this is just e times e to the power of n. And then n factorial, this is n plus 1 times n factorial, so cancel out your n factorial. So overall, our limit just simplifies down to the absolute value of e divided by n plus 1. Now, as n approaches infinity, infinity plus 1 is infinity. E, which is some kind of number, is just a number. Divided by infinity is 0. So by the ratio test, since 0 is less than 1, then this is going to be converging. Okay, now let's try another example. Let's say we take the summation from x equals 1 to infinity, and we try x to the power of x divided by 2 to the power of x times x factorial. Well, using the ratio test, the limit as n approaches infinity, the absolute value, substitute x with n plus 1 divided by 2 to the power of n times n to the power of n plus 1, times n plus 1 factorial divided by, now substitute x with n, so n to the power of n, 2 to the power of n times n factorial. Close your absolute value. That's equal to the limit. So dividing is the same thing as multiplying by its reciprocal. So n plus 1 to the power of n plus 1 to n plus 1 times n plus 1 factorial times, now we move the denominator to the top and numerator to the bottom. So 2n and 2n plus 1, that leaves behind a 2. N plus 1 factorial and n factorial, as I done earlier, was just n plus 1. So this n plus 1 and this n plus 1 means I could take away an exponent here. So this n plus 1 to the power of n plus 1 is just n plus 1 to the power of n. Because this is the same thing as saying n plus 1 to the power of n times n plus 1, which is n plus 1 to the power of n plus 1. but since this is canceled out with the bottom version, we're left with this. Now this means our limit as n approaches infinity is equal to a 2 on the bottom, so I'm just going to write 1/2 here. And then we have n plus 1 on top divided by n squared on bottom. It seems like we can combine these two, and we can, because they're both to the power of n. So that's n plus 1 divided by n to the power of n. Now n divided by n is 1, and 1 divided by n is 1 over n. So that's 1 plus 1 over n to the power of n. Now, this seems pretty familiar with the limit as it approaches infinity. That is just e. So the limit as 1/2 times 1 plus n to the power of n times infinity to the power 2 n equals infinity would be 1/2 times e. So is this greater than 1 or less than 1? Well, e divided by 2, e is about something like 2.7 something. So 2.7 is bigger than 2, so this is going to be definitely greater than 1. So since 1/2 e is greater than 1, this tells us that this is going to be diverging. Okay, well that's everything for the ratio test. In the next video, I'll be covering the fifth and final convergence test, the root test.